Hello Year 8. What I would like to do in this short video is I'm going to show you how to use the virtual laboratory that you are going to use to investigate how the number of pumps on an air pump affects how many particles collide with the walls of a container. Okay, now what you will need to do is you will need to open up the link that will take you to the virtual laboratory. When you get there, this is what you will see. You'll see two options, one called Intro and another one called Laws. The one that you want is the one that is titled Intro. And when you click that, this is what you will see. Here we have got a sealed container, and attached to that sealed container we have got a pump, and you will notice that if you click and drag on that pump, that what you can do is you can pump air particles, gas particles, into that sealed container. Now what you are going to be interested in, and what you are going to investigate, is how many collisions there are between the air particles and the walls of this container. Okay, let me just move my face out of the way. Now then, so what I want to do is I just want to show you some of the features in your virtual laboratory. So we'll start over here. This is the pump that you can use to pump air into your container. Okay, when you do this, what I suggest you do, if you just do a little one like that, that's not going to be terribly precise and accurate. So I'm going to suggest that we call one pump, lifting the handle all the way up and then bringing it all the way back down again. Underneath that pump, you'll notice that you've got these two different options. You've got some blue particles and you have got some red particles. Okay, and you'll notice that the red particles are slightly smaller. Now, it doesn't matter whether you use the red or the blue, just in order to make this a fair test, that you only use one or the other. Okay, here, this little bucket thing, what this does is this can be used to heat up or cool down the container. We are not going to be investigating the effect of temperature, so we're going to leave that one alone. Over here, you'll notice that we've got a pause button and a play button. We won't need to worry too much about that. The container itself, you will notice you can drag to make bigger and smaller. We are not going to be investigating how the size of the container affects the number of wall collisions, so we're not going to worry about that. This little device here, this is a thermometer. And the thermometer you can have to read in something called degrees Kelvin, or you can have it reading in something called degrees Celsius. We won't need to worry too much about that. This little gauge here, this is a pressure gauge. So this will tell you, give you an idea of the pressure inside your container. And there are two options for the units that you can choose. You can measure it in something called atmospheres, or you can measure it in something called kilopascals that we will have discussed in a previous lesson, but we won't need to worry too much about that. Over here, if you put a tick in the width box, it will just tell you the width of your container. We don't need to worry too much about that. Here we've got a stopwatch that you may want to use as part of your investigation. And most important of all, we've got this thing called a collision counter. Okay, you will need to make sure that you have got a tick in that little box there that says collision counter. Underneath that, we've then got this thing that says particles. If you click the cross, it will allow you to change things about the particles that you're going to put into the container. We're not going to worry too much about that little box, so we can ignore that one. Okay, down here, this little reset button, if you make a mistake, if you've messed it up completely, all you can do, just click that little button and it will reset everything. Okay, right then, I need to have my collision counter ready. Now, a little word about this. What this will do is it will count how many times an air particle hits the sides of the container, and you can choose the sample period. Okay, so you can choose how many collisions there are in 5, 10, or 20, what are called picoseconds. 1 picosecond is 1 trillionth of a second. I'm going to suggest that you keep it set at 10, because obviously that's something that we're going to want to keep the same for each test that we do in our investigation. So here we've got my experiment all set up, and the first test that I am going to do is I'm just going to add 1 pump of air to our container. So here we go, I'm going to add 1 pump of air, and you'll notice, look, that we've put some air particles, some gas particles into our container. Now I'm going to let it just leave it just for a minute or so, just to let those particles spread out. Okay, what I'm then going to do is I'm just then going to press the triangle play button in the wall collisions box, and when I do that, what it's going to do is it's going to count how many times a gas particle collides with the walls of the container in 10 trillionths of a second, 10 picoseconds. So you can see here, look, that there were 36 collisions between the gas particles and the sides of the container. Now, the beauty of this virtual laboratory is that it does put a little bit of randomization into it. So just like we normally do in school, when you repeat an investigation, we can repeat this one. So what I'm going to do, that time I got 36, I'm just going to press the green triangle again. It's going to count the collisions again. Okay, here we go. And this time I got 30. Okay, I can then add another pump of air. Okay, give it a little minute to spread out. I'm then going to count the collisions again now with 2 pumps of air. Okay, and that's what you're going to do. So you are going to investigate how the number of pumps of air affects how many times the gas particles collide with the walls of the container. All the instructions for this investigation I will have posted you in Edmodo and discussed with you in our live Teams lessons. Hope you're well, and I'll see you soon. Bye!